In response to maritime industry needs, Tideland Signal applies a broad range of technologies to develop and manufacture marine navigational aids for lighthouse, port, harbor, and coastal authorities, and the offshore oil and gas industry. Inside Tideland Signal's Houston headquarters is their optics laboratory, with a 55-meter light tunnel with a Class A goniometer. This fully automated data acquisition system evaluates and compares light performance in accord with IALA recommendations, using a traceable standard lamp. The system's photodiode detector is compensated to replicate the CIE definition of the color response of the average human eye. Calibration against the CIE response curve permits precise determination of spectral correction factors for a light of any color. The control computer is programmed to scan either the horizontal or vertical axis, recording an intensity measurement for each angle setting. The result is the average human eye's response to the viewing of that light. To perform a full scan of an omnidirectional light, the light is mounted on the goniometer table with the optic plane of the lens passing through the horizontal axis of rotation and the light leveled and oriented. As power is applied, input voltage and current is monitored with precision digital meters. Key descriptive information is entered into the computer to become part of the record. Once calibration and setup is complete, the master control computer assumes full command. The horizontal scan angle operates in stepped increments of either 1/10 or 1/2 a degree, with the angular setting and corresponding intensity recorded. After a rotation of 360 degrees about the vertical axis, 3 vertical scans are performed automatically at 120-degree intervals. When data acquisition is complete, a single computer command produces a complete graphic record of the scan process, including 1 polar horizontal plot and 3 Cartesian vertical plots. This graphic record includes pre-entered data as well as post-measurement annotations. Similar procedures measure and record the intensity profile of a pencil beam light. The limited angular ranges of the horizontal and vertical profile scans are preset. Both scans are performed in 1/10 degree increments. The graphic record includes Cartesian plots of both the horizontal and vertical profiles, along with pertinent data. If the light is flashed, a rapid response photometer system is used to record the time-dependent intensity profiles of the light. The recording procedure includes the performance of the intensity-time integration required for the determination of effective intensity. This system is also used to determine the relationship between peak intensity and duty factor for LED lights. Chromaticity measurements performed on light serve 2 purposes. First, chromaticity coordinates for the light must fall within specified boundaries for that light color. Second, spectral measurements are used to determine the spectral correction factor entered into the goniometer data acquisition process. In accordance with IALA recommendations, Tideland recently tested similar marine lenses in their optic light tunnel. It could be assumed that lens A would have a higher effective intensity due to a slightly larger focal length and a taller aperture. However, the test result confirmed that the smaller lens B produced 45% more light than lens A. The 2 main causes for low intensity of lens A are poor optical quality during the molding process and an inferior mold design of the optic dimensions. This illustrates the importance that manufacturers of marine navigational aids authenticate product performance. Tideland Signal recognizes its responsibility to meet and exceed IALA standards, guidelines, and recommendations. Lives depend on it.